All right, here we go with lesson 7.4b. This is the last lesson of chapter 7. So we're wrapping it up. We'll look at a quiz at the end of this week, and then we'll be taking our chapter test next week. All right, so we're going to take the objective functions that we learned how to graph yesterday and put them in the context of an application, of a real-world situation where there are limitations and constraints, but you still want to find the best solution possible. So I'm going to give you some techniques on how you can work through those, and then hopefully you can apply that and do some of these on your own. All right, let's look at this first example. A manufacturer wants to maximize the profit for two products. Product 1 yields a profit of $1.50 per unit, and product 2 yields a profit of $2 per unit. These are the following constraints. The combined production level should not exceed 1,200 units per month. Number 2, the demand for product 2 is no more than half the demand for product 1. And finally, the production level of product 1 is less than or equal to 600 units plus 3 times the production level of product 2. Okay, you look at that and it's just like wow, this whole huge problem, and there's so many words and numbers, and how do we figure this out? Well, I've tried to come up with sort of a template of how to attack these problems step by step in a logical way that hopefully will help you bring some order to the problem. So first things, step A, state the variables. The variables are given to us in the very first sentence. A manufacturer wants to maximize the profit for two products. All right, so those are our variables, product 1 and product 2. So clearly state what those variables are. All right, so X is product 1, and I'm going to have Y stand for product 2. The second step, part B, is you want to identify the objective of this problem. Now, as with most companies, the objective is to make money. That's the goal. And in this case, we want to maximize the profit. And so after we identify that, we write, all right, I want to maximize the profit. And how am I going to do that? So I need a function for that, which is another word for an equation. And we can see that we are told that we get $1.50 for every unit of product 1. So that would be 1.50x. Plus, we get $2 for every unit of product 2. So that's plus 2y. And that is your objective function. Now, there's always, within the constraints, there's other things you have to work in. And we're talking about the production level. And so in part C, it's always a good idea to identify what is not part of the objective. Okay, the objective is profit. All right, once you've dealt with the objective and you've used up all the numbers for profit, we're not ever going to refer to this sentence again. Okay, we're pretty much done with it. And so this problem is lined up for us. We are now wanting to know about production. And so every part of our system now has to do with production. Now I've laid it out pretty clearly in this one. There are 3 statements that lines up with 3 equations. It's not always going to be this cut and dried, but I thought for our first one we would start that way. So constraint number 1, the combined production level. Okay, well, combined production level of the 2 products, so that's X plus Y, the combined production level, should not exceed. Now you've got to think about those words in terms of greater than or less than. And when something should not exceed, it means it needs to always be less than or equal to 1,200. It just can't be more than. It can be equal to, but not greater than. Statement number 2, the demand for product 2 is, product 2 is Y. The word is always translate into, okay, and some kind of equation or equal sign. What is it? It is no more. If it's no more, then it is less than. And what is it less than? Half of the demand for product 1. So that would be 1/2 times X, or Y is less than 1/2 X. Then statement number 3, the production level of product 1, that's X, is less than or equal to 600 units plus 3 times the production level of product 2, so 3y. Okay, our system is ready to go, except that it's not quite in the right order. So we would need to do some rearranging of our system so that it looked like the systems of yesterday. You want the variables all on the same side, if possible. That makes it easiest to graph in terms of the intercepts. So for the second system, I'm going to subtract. I'm going to subtract -1/2 x from both sides, and that's going to give me something different. So I'm going to rearrange this. I'm going to erase what I had, and I'm going to put -1/2, -1/2 x plus y is less than or equal to, now I have nothing left on that side. All right, so keep it with your 0. All right, we're going to do the same thing for the final equation. I'm going to subtract 3y from both sides, and that will give me the equation that looks like this. Okay, take this out. And we're doing this so that it's easier to graph. X minus 3y is less than or equal to, and we had 600 left on that side. Okay, now we are ready to graph our system. So we're going to think about what we did yesterday in terms of the intercepts. For the first equation, the x-intercept would be 1200 if I did not have a y value, and the y-intercept would also be 1200. For the second equation, again, remember, if you don't remember this technique from yesterday, you should go back and watch the video on how I'm doing that. But if we did not have a y, we would be looking at, if we did not have a y, x would be 0. And if we did not have an x, y would also be 0. So we're looking at the corner 0, 0. And then we've got x minus 3y equals 600. I'll do that in green. So x would be an intercept of 600. And y would be an intercept of negative y equals negative 200. All right, and then we are ready to graph. We are going to have to come back to this one here because that gives me 0, 0, and that's we'll talk about what to deal with that in a minute. Let's do the red and the green. So 1200 connected to 1200. So I need to mark out 1200 on my graph. I'm going to count by 200s, I think. So 200, 400, 600, 800, 1000, 1200. And I'll do the same thing. 4, 6, 8, 10, 12. All right, so we have 1200. And we'll connect those two. And because the equation of the inequality was less than, I'll be shading below. Let's do the green one. X is 600 and y is negative 200. So let's see, 600 is here. Negative 200 would be right here. And so when we connect those, my equation will look like this. Also shading that one below. Finally, we've got 0, 0, which is not even in the region that we're talking about because we have to stay below the red line, below the green line, and we need to stay in the first quadrant. And so we can throw out the blue because it's not even in that region. So let's shade what we're looking at all together. So we are looking at this triangular section. And so we need to identify our corners. And so we've got the corner 600, 0. Oh, goodness. Okay. We also have the corner 1200, 0. And finally, we've got this third corner, which we need to find. So that is the intersection of the red line with the green line. So we'll do a little math to help us figure out what that intersection point is. So my red line was created by the equation x plus y, and we'll do equal to 1200 because when you solve for that, again, if you're not sure about that, you're going to have to watch yesterday's video again. And then we've got x minus 300, excuse me, x minus 3y, and we'll do equal to 600. And so we want to, I think, triple maybe the top equation. If I did 3, 3, and then if I tripled that one, I'd have 3600. That's one way to do it. You could have gotten rid of the y's, the x's too if you wanted. And we've tripled everything. All right, so we have 4x equals 4200 when you add those two together. And so x would be 4200 divided by 4, which is 1050. And then we need the y value to go with that. And the y value to go with that is 150. And so my other corner point is 1050, 150. All right, once I have my corner points for the 3 corners of this triangular region, I'm going to check each of them in my goal, my objective, which was max profit. And I'll look back at what my max profit objective function was, and it was $1.50 for every x and $2 for every y. So that would be 600. Well, let's do $1.50 first. $1.50 times 600 plus $2 times 0. Or it could be $1.50 times 1200 plus 2 times 0. Or it could be $1.50 times 1050 plus 2 times 150. One of those combinations is the maximum profit altogether. And I'm kind of out of room, but I am going to just write it off the page. All right, that one, $1.50 times 600 is 900. Next one, $1.50 times 1200 plus 2 times 0, that's 1800. And the last one, $1.50 times 1050 plus 2 times 150 is 1875. And there we have it, our winning maximum value. And so to answer the questions, how many of each variable will meet the objective? Well, we want 1050 of product 1, and we want 150 of product 2. And our goal, the value of our objective, is a maximum profit of $18,075. So that was a template of how to tackle a word problem. Now this first example was all nicely numbered for you. It all worked out. Not all of them are going to be set up that way. So let's take a look at a second example and see if we can still use the template and if it will still work for us. All right, it just was tax season, and so let's look at a CPA firm. An accounting firm charges $300 for a tax return and $2,000 for an audit. They want to maximize their revenue each week. A tax return takes 12.5 hours of staff time and 2.5 hours of review time. And an audit takes 100 hours of staff time and 10 hours of review time. The firm has up to 900 hours of staff time and 100 hours of review time available per week. How many tax returns and audits should the firm do in order to maximize their revenue every week? Again, there's all kinds of numbers and variables. How do you decide what's the variable and what's the objective? So, pro tip, variable is often found in the question part. And so in this problem, the question is at the end. And the question is, how many tax returns and audits should the firm do? There's your key to what the variables are going to be, the tax returns and the audits. So let's clearly state what those variables are going to be. So we want tax returns. And then we'll have Y be the audits. Often, also in the question, you'll find your objective. In order to maximize their revenue, that is the objective. max revenue. Once you have established what the objective is, go back and look through the problem for any numbers that have to do with revenue. Now, revenue is a dollar amount, and I see $2 amounts here. I see 300 and 2,000, and those are going to be part of my objective function. So 300 was for the tax returns, and 2,000 was for the audits. Now, remember, once you have finished your objective function, those numbers of 300 and 2,000 are not going to show up again. Okay, they're finished. We're done with it. So I'm literally going to like cross it out. Okay, I'm not going to use that sentence again. Now, part C, what constraints are not part of the objective? The objective was revenue, but this problem also talks about other things. So the other things it talks about are staff time and review time. Now, some people think those are the variables. They're not. They are the constraints. The variables are always in the question. So the tax return and the audit are the variables. These things of staff and review, they're what are called the constraints. Now I have two constraints, which means I will need to write two parts of my system, one for each of the constraints. So the first constraint part of the system I'm going to write is only going to deal with staff. Don't go mixing things up and trying to do some of each. We are only going to be looking at staff. So I'm going to color code my problem, and I'm going to pick out the numbers that talk about staff. I've got 12.5 staff time here for a tax return. I have an audit, takes 100 hours of staff time, and the firm has 900 hours of staff time. I am not using the review time at all right now. You can't mix your constraints. You just isolate the values that have to do with the particular constraint you're looking at. My constraint is staff. So I turn that into a math problem. A tax return takes 12.5 hours, so that's 12.5 for the variable of the tax return, which was X. Then I have the audit, which takes 100 hours of staff time, so that would be 100 Y. The other thing I highlighted was the number 900. Up to 900. That means no more than 900. So this is not going to be equal to 900. This will be less than or equal to 900. Then I'm going to deal with my other constraint. Right, my other constraint is the review time. So again, I'm going to color code. I've got 2.5 hours of review time, and then 10 hours of review time, and then the firm has up to 100 hours of review time. So now I'm going to write my constraint that has to do with review time. A tax return takes 2.5 hours. So 2.5 X plus 10 hours of review time, that's 10 Y, and up to 100 hours. So again, less than or equal to 100. Now my constraints are set up, and that is what I'm going to graph and stay in the first quadrant, and then find the corners of this system. All right, so I'm going to use my same graphing technique that I did before by finding the X values and the Y values. Okay, let's see. For the first equation, the intercepts, if I have no Y, then it will be 900 divided by 12.5. So I'll have 912.5. And then the Y, whoops, nope, that's not right. Try that again, 900 divided by 12.5. 72. There we go, that's better. All right, and then the Y value for that intercept that I'll be graphing would be 900 divided by 100, so 9. So I need to connect 72 and 9. And then my other equation, if I'm graphing intercepts, so 100 divided by divided by divided by 2.5. So x is 40 and y is 10. Okay, I'm going to do this one in red, and I'll do this one in green just for color coding purposes. All right, so looking at the numbers, I've got 72, 40, 10, and 9. So I'm going to count by 10s on my graph. 10, 20, 30, 40, 50, 60, 70, 80, 90. So 10, 20, 30, 40, 50, 60, 70. So 72 would be about right here-ish. And then we're going to be connecting that to 9 on the other side. So I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to connect those two. And I'll be shading below because this is a less than equation. Whoops, I said I was going to do that in red, didn't I? Okay, let me change my color here. All right, there we go. And then the green one, green will be going from x is 40 to y is 10. So 10, 20, 30, 40 here. And y is 10, that would be here. And I will connect those two, and I'll be shading below there. So below both of those lines, but within the first quadrant. So I am not shading that teeny little empty piece right there, but I'll stay. It's not quite a triangle because the top of the triangle is cut off a little bit there, but there's my shading value. And so this triangle, or it's not really a triangle, it is a quadrilateral because there is another intersection point right there. Oops. So I'm going to have to find that intersection value. All right, so what are my corner points so far? Well, 0, 0 is a corner point, of course. Then another corner point is the 40, 0. The corner point on the y-axis is 0, 9. And then my job is to find the intersection of the two constraints. So let's take a look at what I want to do with I've got 12.5 x plus 100y, and we're going to set that equal to 9,000 when we're finding the intersection. And then I've got 2.5x plus 10y equals 100. So I added an extra 0 there. Okay. So I think I'm going to multiply everything by negative 10. So when I do that, I multiply everything by negative 10. That will give me negative 25x minus 100y and minus 1,000. And I'm ready to eliminate. So when I eliminate, I get negative 12.5x equals negative 100. And so I divide both sides by negative 12.5. And x turns out to be 8, right on the nose. So if x is 8, I should be able to figure out what my y value is. When I plug 8 back into one of the original constraints, I get y is 8 also. So that's my fourth corner point, which is 8, 8. Once you have the 4 corners, now you're going to check them all in your max revenue equation. So remember what our goal was. Our goal was to find the max revenue for this CPA firm. And so this is going to be 300 times 0 plus 2,000 times 0. Well, that doesn't equal anything very exciting. That's 0. That's a terrible revenue. So it's not going to be that one. 300 times 40 plus 2,000 times 0. That's going to give me 1,200. How about 300 times 0 tax returns, but 2,000 times 9 audits? What's that? Well, that's 1,800. That's even better. But the sweet spot, well, maybe. let's check if we did 300 times 8 tax returns, and what if we did 8 of each? That's 2,400 plus 1,600. And so or 16,000, excuse me. And so think, I missed a zero. Did I miss a zero? I missed a zero twice. There we go. So when we add up 2,400 plus 16,000, we get 8,400. So that there is, like I said, that's the sweet spot where we're going to have our maximum amount of revenue. So to answer the question, how many of each variable will meet the objective? We want 8 tax returns, and we would like 8 audits. And that is what this company should have as their goal, so that their revenue is $18,400 for that tax season. So that template helped us organize this paragraph into something that we could chunk out into manageable, workable steps. So let's try that one more time and see if we can apply it in a third situation. The liquid portion of a diet is supposed to provide at least 300 calories, 36 units of vitamin A, 90 units of vitamin C daily. A cup of dietary drink costs 12 cents, but provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of dietary drink Y costs 15 cents and provides 60 calories, 6 units of A, 30 units of C. How many cups of each drink should be consumed each day to minimize the cost and still meet the daily requirements? All right, so giving you this template to work with, we want to find our variables. Again, the pro tip is that the variables are often found in the question part of it. And so the question is, how many cups of each drink? The drinks are the variables, not the calories, not the vitamin A, not the vitamin C. The drinks are the variables. And so I've got X is going to be my drink X, and Y will be drink Y. All right, also, often in the question will be your objective. And the objective here is to minimize the cost. So I want minimum cost, which means I need to look back through the problem and find anything that would give me a clue as to cost. So we look for the value of 12 cents for the cost of the dietary drink X, and 15 cents. So I'm going to have 0.012 for X plus 0.15 for Y. Once you've dealt with your objective, you will not be using those numbers again. So sometimes I just literally obliterate them so that I'm not tempted to have them show up again in a different question. The constraints that aren't part of the objective, okay, they're not variables, they are constraints, are calories and vitamin A and vitamin B. So I have 3 constraints this time, which means I'm going to need 3 parts to my equation. And so again, I would encourage you to color code the numbers to help you not mix up different kinds. Okay, you can't, it's really tempting. I see it lots of times for people to say, oh, well, all of these come right in a row, 300, 36, and 90, and they try and force them into, I'll say, oh, 300 must equal 36A plus 90B, or 90C for, okay, that's totally not the point of the problem. First of all, my variables aren't A and C. My variables are X and Y. A and C are part of the constraints. And so I need to go back and look at this again. Right, so it's just because they come in a row and in the problem does not mean they go together in an equation. What goes together in an equation are like terms. So color code it. right? At least 300 calories. I've got 60 calories, and I have another 60 calories. Okay, the calories are what are going to form my equation. Okay, not a mixture of calories and vitamin A and vitamin C. All right, so I've got 60, oops, switch. Okay, 60 calories in dietary drink X, and 60 calories in dietary drink Y for at least 300. Okay, the word at least means it has to be greater than or equal to 300 calories. All right, I'm going to color code my next part. Okay, now I want 36 vitamins. Again, it's at least 36 units of vitamin A. Here I've got 12 units of vitamin A. Here I've got 6 units of vitamin A. The 12 units of vitamin A are in the sentence about dietary drink X, so that would be 12X. And then 6 units come in the sentence about dietary drink Y, so 6Y, and at least 36, so greater than or equal to 36. The last constraint we're dealing with is vitamin C. So we have 90 units of vitamin C at least. Dietary drink X has 10 units of vitamin C, and dietary drink Y has 30 units of vitamin C. So that sentence would turn into the equation 10 units in the X drink, 30 units in the Y drink for at least 90. Now the at least turning into greater than means all of this shading is going to be shaded up, shaded above. So let's figure out how we can draw these, and I will try and color code again. Okay, using my technique of intercepts. So in this case, X would be 5 and Y would also be 5. For the second equation, X would be 3 and Y would be 6. And for the final equation, X would be 9 and Y would be 3. And so in terms of colors, I will try to assign them this way. I'm going to do, I think, red and a blue, and I'll do a green. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'll do my red one first. 5 and 5. So I've got 5 here, connected to 5 here. And I'll be shading above that line. My blue, X is 3, Y is 6. So X is 3 here, Y is 6 here. Those two will intersect each other, and I'll be shading above that line. And then finally green, X is 9, okay, that's all the way out here, and Y is 3. Okay, so connecting that. Now I need to shade my region within quadrant 1, but above all of those lines. So I'm going to come down the y-axis here, turn the corner at the blue, and then turn the corner again at the red, and then turn the corner again at the green, and then turn the corner at the axis. So my shading will all be this section right here. And I'll need to find the corners that go with each of those places where we turned, kind of changed direction. So my solutions fall somewhere in here. And we want to find what would be the, any of these solutions would be a solution, but which one is the best solution, okay, meets the objective, which is to minimize the cost that we're spending. So I see a couple different intersection points or corner points here. We've got a corner point right there, We have another one here. We have another one here. And our final one is right there. So let's work on finding our corner points. The first corner point on the y-axis is the point 0, 6. Okay, the next corner point is the intersection of the blue line with the red line. So my blue came from 12x plus 6y being equal to 36, and then intersecting with the blue line and red line. So 60x, 60y, and 300. So that's the first system that we would solve. If I look at that, I would go with, I think, multiplying by -10. I think that will quickly clear out the y values if I multiply everything by -10. So if I do that, this bottom equation would become -120x minus 60y equals -360. That way the y's cancel out. I'm left with -60x equals -60, so x is 1. And if x is 1, y has to be 4. That's the only way that that equation works. All right, so this is the 0.14. So I have another corner to add to my list, 1, 4. Let's find the corner intersecting the red line with the green line. So red is, again, 60x plus 60y equals 300. And then the green line was 10x plus 3y equals 90. And I think for elimination, I'm going to multiply the bottom row by -6. So that will give me -60x minus 18y equals -540. Oops, I missed a 0 here, which means I'm missing a 0 here. All right, the x's cross out. 60 minus 180 is -120y equals -240. So y is 2. And if y is 2, then x must be 3. And that is the next intersection point that we've got going. So 3, 2. And our last intersection point was on the x-axis at that value of 9. All right, those are the 4 corners, and one of those has the sweet spot of being the place where we would meet our objective of minimizing our cost. So our objective is to minimize cost. We do that by multiplying 12 cents times the x value and 15 cents times the y value, and then we'll do 12 cents times the second corner point and 15 cents times the y, and 12 cents times 3 and 15 cents times 2, or 12 cents times 9 plus 15 cents times 0. All right, one of those is going to be our minimum cost. So I'm going to switch to white so we can see it a little bit better. All right, the first one, when we multiply, we're going to get 90 cents. For the second one, when we multiply and we add up, we get 72 cents. For the third one, when we multiply and add, we get also 72 cents. Oh no, 66 cents, excuse me. And for the last one, we get $1.08. Remember, we want this time the minimum cost. And so we recognize that the minimum cost occurs in the option of 3 and 2. Therefore, how many of each variable will meet the objective? we want 3 cups of drink X, and we want 2 cups of drink Y. That will help the person who's drinking this to meet all of their dietary goals, but will also allow them to minimize their cost at 66 cents per cup for an overall goal. All right, I put blank forms of this template in Canvas. So if this is helpful to you, there are 3 questions assigned for homework. And so you can duplicate that 3 times and use it. If you don't find this format helpful, you just want to do it on your own paper, that's totally fine with me, whatever works for you. But I did put blank one there for your reference if you want to. All right, good luck with this last assignment of Chapter 7. And we'll have a Zoom conference to go over it, and then we'll quiz on this on Friday.